Hi, this is Ashlee Culmsee. I recently made a fidget spinner in PowerApps for a contest that Microsoft put out, and a few people online asked me how it was done, so I'm here with my dad.
Hello, this is Paul Culmsee.
Who isn't great at maths.
That's an understatement.
I'm going to try to explain to him how I did it, and he's going to build the app himself. Also, if there are any weird noises, there's a cat in the room. He's probably just wandering around doing whatever cats do.
But that's fine. So show them the prize-winning effort that you did.
Ooh.
And so I guess we should say, because one of the conditions of the competition was there is no animated GIFs in here, there's no videos that you've done. This is all legit. You've used objects inside PowerApps and just used, I guess, a bit of trigonometry to move all these objects around, yeah?
Yep. So essentially the design of the spinner, it's made up of 8 circles. So there are 2 middle circles, although they could really have been combined into one circle. The very middle circle is kind of just for aesthetic purposes.
Mm-hmm.
But yeah, there are 2 middle circles. And then we have the 3 arms, and they move around in a circular motion all around that, around the middle.
Yep.
And then we also actually have 3 little invisible white circles here.
Yep.
And so they also move around in the middle. And that's what gives the little cutout sort of impression.
Yeah,
that makes
that nice fidget spinner effect.
Makes it look like makes it look like it has arms.
Cool.
Did use actual images that I cut out of a picture of a fidget spinner.
But why don't you show them? You did a test one before that, right? That was the one that was all nicely done. But your original one.
This is what I did to work it out originally, and so it does not look great. It looks a lot ugly, and this one doesn't have the curved circles in between. But once I did this, I realised that that's what I'd need. It actually has arms. But yeah.
And that's basically what I'm going to do. So I'm not going to go the full effort.
So Dad's going to make this, but with the white circles in between, so it actually has arms.
Awesome. And you're going to kind of explain the math as we go?
Yeah, I'm going to try and keep it simple. Simple as I can make it.
Dad, simple?
I'm going to try and explain it. It's easier to follow along and understand.
Excellent. And
hopefully enough that Dad can understand it.
Exactly. And I'm taking that in a positive light. And we're going to have 2 screens going on. So I've got my PowerApps desktop all blank and it's all ready to go.
What we want to do first...
Just put a circle on, right?
What we want to do first is just put the middle of the spinner. Okay. So I've called mine the body on mine.
The body, all
right. But I've called it, in my instructions, I've called it the middle image.
Okay, so what I'll do, I'll put a circle on the screen. It's just an arbitrary size. I've just put it somewhere. Okay. As you say, I'm going to rename it and we'll call it middle image. And also, for those of you that don't know PowerApps, I held down Shift. If you hold down Shift when you resize images, it means the width and height are the same. If I don't do that, it becomes a warped circle and things won't look right if you do that.
It needs to be a perfect circle.
So there you go.
And if you're unsure if it's a perfect circle or not,
you can just go and have a look. Yeah, so if you have a look onto the side, under the properties little tab, you got size and you can see that the width and height are the same at the moment.
Yes.
So Ashlee approves of that. So we got our circle.
You can put it wherever you want on the screen.
Yep. And so I'm going to do it there and we'll work from there.
Okay. So this spinner uses a concept called uniform circular motion, which is essentially just something, or like an object, moving in a circle around a point at a constant speed.
Okay.
So the point is going to be the middle of that middle image. Okay. That's what it's moving around.
Where my Mr. Grabby hand little thing is.
Yep, cool. So that's where it's moving around. The cat is breaking the printer. Okay, so uniform circular motion uses trigonometry.
Yep.
And so that's sine, cos, tan.
Yep, which I haven't done since high school and I barely remember it. So how would you explain to a noob like me?
So it all essentially works on the premise of a triangle. Most people remember it from the triangle. So if I draw one, it's usually a right-angled triangle is what everyone... Wow, that's a dodgy triangle, but that's okay. Right, so essentially you'd choose an angle, yeah?
Yes.
And sine equals opposite over hypotenuse.
Yep.
So the hypotenuse is over here.
That part, yep.
Opposite is over here.
Yep.
So that means sine of...
that angle there.
is opposite over hypotenuse. And so we usually do it in a unit circle, meaning that the hypotenuse is always 1.
Okay, yep.
Right?
Oh, that makes sense. So
because it's always going around the circle.
So it's assuming they're a radius of 1.
Yeah, unit circle always has a radius of 1. And that's what we generally use to base all our calculations off.
Beautiful.
So if you wanted to work the height of the circle, that would be... hypotenuse is always 1, right?
Yeah,
So opposite over 1. So that's just going to be the opposite angle.
Okay.
I mean, the opposite side.
Oh, yep.
So the height of that is just going to be sine of whatever this angle is.
Okay, so draw one on, like, in the circle.
So if we were doing this here, if you wanted to work out here, which is approximately 45 degrees.
And that's a hypotenuse of 1, gotcha.
So that's a hypotenuse of 1.
Yep.
If we want to work out how tall this is...
Yep, that's what sine gives you.
The angle here is approximately 45 degrees, so you'd say sine 45.
Yep.
And you plop that into a calculator, it would give you 0.71, and that would be the height.
Okay.
And that's all in degrees. In maths, most calculations are actually done in radians.
And what's the difference between degrees and radians?
Degrees are rarely used. It's essentially just a different measure. It's kind of like meters versus centimeters versus inches, you know?
Sure.
So the calculation is essentially 180 degrees is equal to pi number of radians.
Okay.
Right? So meaning 180 degrees is a semicircle, so that's pi. So a full circle is 2 pi.
Okay, so that makes sense. So basically 180 degrees is pi, 360 degrees is 2 pi. Okay.
Yeah.
That makes sense, I get
cool.
that.
So if we were to graph this, let's go for a sine graph first.
Yep.
Sine graph. The y-axis is going to be like the result of sine whatever angle it is. Usually we call it theta. That's just our standard, like instead of x or y, our standard variable for angles is theta.
Okay.
Yep. So that's going to be the result of sine theta, so that's going to be a number, and we are going to do it from 1 to... That's not quite even.
That's close.
-1.
And that's because you were saying that a standard circle is just...
Yeah, that's because we're doing it with the unit circle, so the most it can ever get to is going to be the, 1.
That's the important
That's
bit,
the
right?
biggest the radius will ever get to.
Okay, yep.
Right? And across the x-axis is the degrees. The radians.
Okay.
So whatever angle.
Yes.
Okay?
Yep.
So as you move a bigger angle, for example, as you go from that'll be like here or something. As you go there, it'll be further along and further along.
Okay.
As it moves along the circle.
Yep.
It gets further along here.
Yep. Gotcha.
Cool. We know that the entire rotation of a circle is 2 pi radians.
Yeah.
Right?
Yep.
So that's going to be how far our graph goes before it starts to repeat itself.
Okay, so basically that bit you've marked on the end is 2 pi radians.
That's going to be 2 pi.
2 pi, yep.
And so that's called our period, which is essentially just how far the graph goes before it starts to repeat itself again.
Yep, understand.
Cool. So then in the middle we've got our pi.
Yep.
And then we'll split it into quarters just for it first. And I'm going to do it in red just to make it a bit different. So the first point here is going to be at 0.
Okay, that's it.
Yeah, and the height will be, because it's all the way over there,
0.
the height's 0.
Yep.
Right. So
therefore it starts there. Okay,
starts at 0. Now we're going to go up a quarter, so we're going to do here.
Yeah, okay.
And the height there
it's going to be 1.
Is 1.
Yep.
Yep, at that angle, which is there, it will be 1.
Yes.
At this one...
Yep, that would be back to 0 again.
And at this one...
And don't tell me, -1.
Yeah.
See, I can do math.
And then when we get back to 2 pi...
Oh, when we get back to 0. That threw me there for a second.
Cool.
Okay, now I get that. And so...
Now, you can see it's already starting to form a curve, but we're only taking 4 points there along the circle. So if we took more points, for example, here...
Yes.
That point along that angle...
Yeah, that
would reach about here. If I fix up the graph so that it's actually what it should be...
Yeah, so that 1 should be up a little bit. Okay, now... Yeah, okay.
That was the issue that we're having there. It's just that the 1 should be... Really, it should be there.
Yeah, we're parallel to that top point.
Because that's the height.
That makes more sense now.
Yeah.
And then you could draw the other little point at that 45 across in the same way.
My diagram was just very dodgy. So
that's better.
So then that point there, it's about 45... Well, it's not really 45 because that would be degrees.
Yeah.
So that would be...
That makes
pi divided by 4.
Oh, yes. That makes sense because pi was 180 and therefore half a circle and you're doing...
Yeah, so we've got pi here.
Yep.
Half of that is pi, half pi.
Yep.
With here we've got quarter of pi.
Okay, I get it.
Yep,
I totally get it.
It's just split along, and it's easier to do it this way because pi and 2 pi are like solid values that you can just divide into whatever segment you want.
Yep.
And so then if over at this point, that's approximately
about
here.
Yep. That would be
about
coming
the
down
same,
again.
but on the other side.
Yep.
And then if we did that all the way along the circle, here and here.
Yeah, I see now.
There. And there.
Yeah, and you can almost see already if you drew a line over that.
It's already starting to be the curve. And so if we did more and more points...
Yeah, draw a couple in so people can see. Just like colour them in, but we don't have to line them all.
You know, it would be about there. That one would be about there.
Yep.
You know, as we go along, it will essentially...
And then we've got our...
Oh, that is such an unsmooth graph. But it would essentially make that.
Okay, I get it.
And it would keep going in both directions depending on how many times you went around the circle.
Yes,
you know?
Makes sense.
So yeah, it kind of makes this, that's what we call a sine graph.
Okay.
And so that's where we get the sine graph from.
And we're going to use that to adjust the x, y values of our circles because that's going to help it move like in PowerApps.
Yeah.
Okay,
so that's the sine graph. And you do the same with the cosine graph, right? Because cosine is the opposite... adjacent over hypotenuse. So adjacent over hypotenuse is always 1, so it's just going to be adjacent.
Okay, and adjacent on that, if you just draw on the circle there or on the circle below, just quickly.
So if we drew a nice little triangle here, at this point and at this point, instead of getting this, we're getting the distance here.
So you're going along the x-axis instead of the y.
So we're actually just looking for this little distance.
Okay. And what does that do? So we don't need to redraw all the sample points with sine. What does that look like as a graph?
If we did work it out, it would essentially, if we made this 1, we made this -1, or something that looks like this.
Yeah, and that makes sense to me because just to make sure I understand that right, on that first point where you got pi over 2, just draw a little circle there. So on this point on the graph, that is 0 because that at that point
would be up here.
Yeah, and therefore x is 0. Like if the x-axis
there's no x value, and so it's 0. It's over here.
Yeah, because so it's the maximum possible value. Okay, that makes sense.
The x coordinate relates to the cosine graph.
Okay.
Right. So x, if you're moving, x coordinates move like this way and this way.
Okay, side to side.
Yeah.
Yep.
X is just along this sort of thing. And so if it's a more positive x number, it's more to the right.
Mm-hmm.
Bigger x number is to the right. More negative x number is to the left.
Okay.
If we make the x value, we're going to call it cosine of the theta, which was over here, how far this goes along. Yeah?
Yep. Yes.
The x value will then start off around here. Yeah, starts off as the furthest across it can get.
Yep. Then it slowly works its way.
It will get to the middle.
Which is that point, yes.
Yeah.
Got it.
Okay, so it gets to the middle.
And then it's going to keep... Then it's going to be negative.
The next point, it gets to here, and it will move
and
right to the furthest to the left that it will ever go.
Yep. And then back again.
And then it goes back
to 0.
And it doesn't. It stays on the same plane.
Okay.
So it goes to there, and then at this point here, it would get back to there. So what we're kind of seeing is it's just going across and then back.
So if we did that in PowerApps and used it for coordinate, we'd basically see the...
If you just put this into PowerApps, your
circle will
just go side to side.
Okay.
We make sine the y coordinate.
Okay.
So y will be the sine theta.
Okay.
Right? So similar to this, it will start in the middle this time, because you can see.
Yes, it will because it's 0, yes.
At 0, which is the midpoint.
Yep.
It will then work its way up here to, and it's going up and down, right?
Yep, so it's going to go upwards first, and then it's going to head downwards back to the middle, then to the, is that right?
Down first.
Oh, really? Okay.
Because, like, go into PowerApps now.
Yeah, all right, so I'm on PowerApps.
Yep. Change your y value of that circle.
So y.
Change it to 0. Now change it to 10.
Yes, okay. No, I understand now. So
change it to 100. It starts in the middle. It will, as the y value increases, it will go lower.
Yep.
To the lowest point it will get to. Then it will go back up to the middle.
Yep.
Then it goes to the highest point it will get to.
Yep.
And then here, goes back to the middle. So that will just move down and then up and then down, and it will just move up and down. I've just cleared and redrawn the graphs again a bit very dodgily, but that's okay. So if we split them into sections just to see what's happening, whoops. So both these are going to be happening at the same time.
Yep.
Right? So if we split them into sections, we can sort of just start to sort of make a bit of a prediction of how they'll move.
Mm-hmm.
So we've got them into 4 segments here. So in the first segment, y is increasing, meaning that it's moving down.
Yep. That's right, we just established that.
Second segment, y is decreasing, so it's moving up.
Yep.
It's again decreasing.
Down.
So it's moving up.
Up, sorry, my bad. Oh, of course, duh.
It's increasing.
And now it's going down again.
So it's going down.
Yep.
So with x, it's now decreasing, so it's going...
decreasing x would be going left.
Yep. Here it's decreasing again, so it's going left.
Yep.
Now it's increasing because it's got positive.
So it's going right.
And it's increasing again, so it's going right. So if we look at what is happening at the same time, what we've got is going down and left. So we'll start at a point, let's put it here.
Okay, yep.
So it's going down and left.
Yep.
Then it's going up and left.
Yep.
Then it's going up and right.
Yep.
And it's going down and right.
Yeah.
And so you can see that's sort of, it's a bit of a diamond, but that's because we only took the points.
Yeah, you're only doing 4.
We only took 4 of the points.
But if you did like 8 or 16, it would really start to look like a circle.
So if we started to split it smaller, you'd get more of this sort of look.
Yes.
You know?
Yes.
So the smaller you make the gaps between the points you're taking,
the more circular
it looks. And the great thing about a sine graph and a cosine graph when you're doing this is if you put it in, it actually, if you set like a timer to be this value, as it increases, it takes every single one.
Yeah, so it's a really granular one.
And so it ends up looking really circular.
Yeah.
And that's how you get a smooth circular motion. So yes, first thing, because it's going to move due to a timer, our spinner is, if you don't put a timer in, it's just going to sit in one spot.
Exactly. All right.
So first things first, put a timer control in.
No problem. So I go to the controls menu and I'll go and find timer, which is, I think there is timer. All right, I'll put timer over here for now.
Just put it somewhere so that we can...
So we won't use it yet, and it's called timer 1, so that's cool.
So once you've got a timer there, how the placement, or how the movement works, the formula to get it to move, we're going to go just the x one, we'll just look at x for now.
Mm-hmm.
So x coordinate is going to equal placement.
Yeah.
So where you want it to be on the screen.
Yep.
Plus A, which is going to be a variable, and the A is the amplitude. So instead of just being 1, it's whatever the radius of your circle is.
Okay,
so it can be like 50. So it can be a lot further away instead of just being 1. So we'll do that later, but right now we just want to get the formula down. So A, and then that's times by cosine of whatever time it is, and then if we have a bit of spacing, like if we want to change where they're placed, but we're not going to look at that bit yet.
Okay.
So we're just going to want that. So to work out the placement, you have to remember that the position of objects in PowerApps, it's not based off the middle.
Mm-hmm.
It's based off the X and Y coordinates. And the X and Y coordinates, how far along it is, it's the left edge for X.
Yep.
And the top of the image for Y. So it's actually this top left corner.
Left corner, okay.
So when everything's moving around, whenever you're placing anything, whatever happens, it's all dependent on that point in PowerApps.
And not the centre, which could mess
And not actually the centre, which is what we generally expect it to be.
Okay.
First thing you got to do to work it out is you got to make a circle shape on top of your middle image there. And the size of the circle determines where the arms are placed and also how big the arms will be.
Okay. Size of the circle determines that. So that's fine. Let me go and add a circle. So I've added a new circle. I'll change the colour so we can see. And I'll call this one... What should I call this?
Just call it circle.
Yeah? That's...
You cannot spell.
No, I cannot do caps lock.
You cannot type.
That's actually probably the more accurate. If you set all your properties in PowerApps manually, the minute you change one, everything will be thrown out of proportion. Whereas we're going to try and set it so that everything is actually quite flexible and movable. So because it's on the left corner, and therefore everything's related to that left corner, I'm going to do this. On this circle here, if I said the X position of this circle, instead of being an arbitrary figure, I'm going to make it, the X is equal to middle image dot X, but that's not everything.
Wait, let's show where it goes.
Okay, yep.
So that puts it over there, but we don't want it to be there. We want it to still be
in the middle.
Over in the middle.
So I think now what we do, if I then add to this, add. If I add middle image dot width, this is how I've done this before. Now you might simplify this, but if I add the middle image dot width, now that of course is pushed it way too far across. But then if I subtract, width divide 2, half of the width. But then if I subtract from that, circle dot width, circle.
You can't spell.
I know, it's terrible. Width divide 2.
Yeah,
Yay!
that's what we want.
There you go. See, and so the y-axis is the same kind of deal, right?
Yeah, you're going to do essentially the same thing, but just with the
so I'm going to cut and paste
instead.
this. Yeah. And so the beauty is, the reason we've done it that way, just to reiterate, if I actually then picked up this blue circle now, in fact I'll do it and move it a bit, the inner circle moves with it, and we don't have to worry about then repositioning
beautiful. It. And call it so what you want to do is copy that and call it arm 1.
Right, copy paste.
That'll be the first arm of
Now I've copied and pasted, but because of the properties, it's put it straight over the top. That's okay. So let's give it. And so now this is coming back to the formula.
Now go to X. Put it at the X position.
Yep.
Yeah.
Yep.
So it's been put there.
Yep.
Then what we did.
Put your bracket back in. Oh yeah.
We added half of the width
to it.
So it's moved over to here, as you see.
Oh, so yeah, that's it.
As opposed to being over here.
It's now exactly the halfway point.
Now exactly at that halfway point.
Beautiful.
And then, if we put that first bracket back in, because PowerApps will cry. And if then we take half of the width of this circle, it puts it
exactly
right
where
in the
we
middle.
need it to be as a start point. Cool.
Yeah, and so then we're going to add.
A.
We'll work on that soon, and then multiply it by cosine.
Cosine. And that's where the timer comes in.
Just put, so the timer 1 value is what we're going to use.
So we're using the timer control we added earlier. Timer 1.
Dot value. And then close bracket. Right. PowerApps is complaining and having a bit of a hissy fit because we don't have a value for A there. A is the amplitude, remember. So that's the distance of how far away it is
from the middle. How far the arm's going to be from the middle.
Exactly. We're going to just make A as the circle width.
Okay. So circle dot width.
And it looks a bit dodgy now, but that's because the Y position hasn't been set.
So let's go talk through the Y position.
Yeah. So the Y position is essentially going to be the exact same code, but instead of cosine, we're going to use sine, and instead of .x, it'll be .y.
Yeah. Ah,
so now
look,
you see it's touching.
Now it is touching. And actually, in fact, at this point, if we started the timer, it should start going.
Yeah, so
should we do a little test?
If you start the timer, you should see the arm should move around anti-clockwise, I think, in a circular shape.
Well, let's find out. Oh, look at that. High five. But we did a high five, by the way. Although that was useful you can tell it's working and it's a perfect circle. That's one of the reasons why we use circle width. We need to push it out a little bit because it's not going to look well when we do the others and the aesthetic.
If you look at it, that's not really a great arm you've got there. I mean, you could just leave it, but if you want it to look...
So let's just...
I mean, you can just leave it, really. If you want it to look a bit better, what you're going to do is just multiply circle width by some
factor.
value.
I'll multiply by 1.2. So if I do that on X now, let's double check. So we'll check where we've gotten to, and I think this is looking good.
Cool. So now all we need to do, we're going to just... At the moment, we're going to add the other two arms, and we're going to do it just by duplicating that.
Okay, so if I just could copy this and paste?
Yep.
Copy, paste.
Do it. Another copy, paste?
Yep.
You want two of them?
Another paste. Cool.
Yep.
So let me
call this... So now we've got three arms. Call them arm 1, arm 2, and arm 3.
Arm 2. Now, of course, they're in exactly the same position right now, just by virtue of saying the same properties.
Fine. So
I've selected arm 2. So what are we going to do?
To change the location of the arms around the body of the spinner, so if you want one arm to be over here or over here, because there are three arms, we're going to want them to be perfectly spaced.
Yes.
Each is going to be 1/3 of the spinner.
Yep.
To do that, what we need to do is it's making it start later in the cycle, and how that works, if we go back to my little notey thing, if we draw, there's a nice little sine graph.
Yep.
Right now, they're all starting here.
Yes.
What you want to do is make them start later on in the cycle. So instead of being in the middle, that middle point, you want one to start maybe like wherever a third is. So I'm just going to put it like over here,
Yep.
You want it to start, and that's at a different point of the cycle, so it's going to be further along in the circle.
Yep. Oh, and that's a fraction of pi, because pi was the whole, like...
So yeah, one full revolution, or one period, right, was 2 pi.
Yes.
Yes?
That was a whole circle, but this is a
That's a whole circle. And because we have 3 arms, we want them to be a third each. So it's going to be a third of the circle, 2 pi over 3. Just divide it by 3. So the first arm, what you're going to do...
So I guess I have to go to the X value, and then
and it's going to be timer 1 value.
Yep.
Right, so that's where it is along
currently now.
The X. Yep. So that's where it is along here.
Yep.
We want to add 2 pi over 3 to that.
Okay, so would that be something like plus?
Yeah.
Inside here.
Do
I bracket it?
You can. I feel safer the more brackets I have.
Okay, yeah, I'm kind of like that too. Actually, if you ever start coding proper languages, you'll be doing that a lot.
Yeah, you got to just be safe.
Yeah, so if I go 2 multiplied by, and there's a function for pi, right?
Yep, and it's great. You just leave, it gives you a little bracket, but you just close the bracket straight away.
2 pi, divide 3?
Yep. And then close that bracket.
And then close that extra. Ooh, now that's okay because we haven't done y yet.
Yeah, so it looks a bit dodgy, but that's fine because you just got to do the same bit to y. And look at that.
Look.
So that's exactly a third away around.
And that means if I start at the timer now, it should just keep going, right?
Yeah.
Oh, look at that.
Except one of the arms actually has 2 arms on top. So the third arm,
3.
If you did 2 pi over 3 on that one as well, it's just going to go on the same spot that the other one was.
Yes,
understand. So we don't want that. So we want another third of the way along.
So would that be 2 pi, divide 3 plus something, or is there
So look, if we look at it, 1/3 is 2 pi over 3. Yeah?
Yes.
We want it to be 2/3 now.
Would that be 2 pi over 1.5? Or 2 pi over...
you can't really do over 1.5. That's a...
Sorry.
That math does not make... 2 pi over 3 is 1/3. We want 2/3. Yeah?
Yeah.
If you look at that, 2 pi over 3 plus 2 pi over 3, what is that?
2/3.
Yes, but what number does that equal? What does that equal? This is addition, Daddy.
Well, so it would be 4 pi over 6.
No.
Well,
What's 1/3 plus 1/3?
2/3. Oh, okay, 4 pi over 3. Yeah, so 4 times pi divide 3.
Yeah.
Oh, okay. And again, I've got to do it for...
Y?
So that was that one. If that stays in, that'll be the end of me.
It's staying in.
You're an evil child. Evil child.
Not...
Oh, and look.
So that is exactly, perfectly, mathematically spaced.
Let's try the timer. Oh, yes. That's just making me happy.
So that's beautiful and all.
Yep.
But it's not quite beautiful enough.
Okay.
Because my beautiful spinner
Yep.
has these nice little actual arms. It's got these little curvy points, which makes it look even more like it's,
Yes.
spinning as opposed to separate things moving around.
3. Okay.
You know? So what we want is these white circles in between that make the nice space.
So this time I'm going to have to just add a new circle because they're going to be a different size to the others, right?
Exactamundo.
Okay.
Most important thing to remember is the circle needs to be ordered so that it's behind the arms, but it's in front of the middle image.
Okay, so let me make him slightly bigger, and then, but let's bring it over here. So you were saying it has to be behind the arms, but then over the middle.
So to test that, just kind of put it in front of everything. Go to home.
Yep.
Reorder it, just send it right to the back at first.
Reorder, send to back.
Yep. And then just slowly bring it forward, because the arms are above, reordered
okay,
above.
let me change the colour so we can see. Whoops. Okay, so now we bring it forward.
So yeah, we want it to be in front of that middle. So yeah, that's perfect.
That's because, that's actually...
You can make the back a bit bigger.
Yep, that's what I'll do, actually.
Yeah. Because right now, it's
And look, because of what we did earlier...
Everything stays nicely.
Isn't that lovely? That just shows you. There you go. Bit of PowerApps, just making use of properties instead of hard-coding values. It makes things very flexible.
Make it bigger. You want to make it so that there are no white gaps behind it, but you also want it to be smooth between here instead of, having this kind of sharp bit in the middle.
Let me just quickly turn it white. We'll have a look and then we'll actually do the math.
Yeah. So is that how you want it?
No, that'll do. That'll do. I think that'll look good.
Cool. We're going to repeat the process, right, that we did with the arms.
The very first arm, kind of like that.
Yeah.
All right.
So,
Shall I go and get the code from the first arm? And
Instead of circle width, we want that circle which I called gap.
Okay, so I'm going to actually, let's deal with that now. Call it gap.
Just so we don't get confused trying to type things in. Cool.
So
make that one gap width instead of circle width.
We don't even need that 1.2
no, we
stuff.
Don't.
That can all just go, right?
Just check. That again is going to be A. So
let me get rid of the 1.2 altogether for a second.
Get rid of 1.2. Just leave it like that. So that's all nice.
It's a little bit off, but we haven't done Y.
We haven't done Y.
So I just cut and pasted the X one to the Y property. So I've got to change that to Y. And what else have we done? Ooh, we've done something weird here.
It's sine, not cos.
Oh, it's sine, not cos. Thank you very much.
That will also make a big difference.
Yes, that'll completely mess with its position. So if we go sine and
so right now, it's going to be where that first arm was. Now, we don't want it to be there. So we're going to go back to our little thingy here. We don't want it to be... right now, it's here. We don't want it to be at 2/3. We want it to be in between 0 and 2/3, yeah?
Yeah.
We want it to be right in the middle here. So what fraction of 1 is that? That's about 1/6, yeah?
I think so. Yeah, that would be right.
Because what we're doing here is we're doing this number divided by 2. Right?
Yes.
2 pi over 3 divided by 2. When you divide with a fraction, you actually
it becomes something over 6
times 1/2.
Yep.
Yeah. So that's actually 2 pi over 6. That point there.
So okay, that means.
So what we're doing, it's going to be timer value. Plus 2 pi over 6, and then you're also going to need to do that.
And we do it on the Y. Yeah, on X. And lo and behold. We've got it in the right position, but it's probably the width is still off. We got too much width, but we can deal with that.
No, that would be the radius.
That would be the radius. Oh, okay.
The amplitude.
Yes, that's what I meant.
So the A value, yes.
The A value.
So where we had there, the A is right now just gap dot width.
Yes.
We're going to multiply that by something.
Like a reduced number, like 0.8, yeah?
Yeah.
I'll do 0.8, right?
with this, at this point, trying to find the value that you need to multiply gap.width by, you're going to have to just a lot of trial and error.
Okay, so now, don't tell me. I think I get this. We've got everything in here, and this will move around like the others
so
if I start the timer. Yeah, let's test.
Yay.
Beautiful. So now I'm going to do this. I'm going to make a copy of this guy.
Yep.
And I'll just do one at a time. So that's gap. This can be gap 1. I'm cool with that. And we go into the X value here and see if I explain this right. Because on the sign graph, we now need to move it to the next position.
How far away is the next position on the graph?
So first
it's here, like that's the first position.
Yep.
This is the next position.
So
how far away is that?
4 times. Sorry,
What?
show me that again.
From here to here, how far away is that?
That is a 1/4 pi.
A third.
A third pi, sorry, a third pi.
No, not a third pi, just it's a third of the entire thing. Yeah?
1/3 of the entire... Yes, it is. Yes, it is, because I can... Yeah, I get that.
Yeah?
Yep.
And what did we work out a third was before?
2 pi over 3.
Yeah. You keep 2 pi over 6, because that's where it is first.
Yep.
Yeah? Then you add 2 pi over 3 to it.
And then I add 2 pi over 3 to it. So I'm going to need to put that...
Wherever there's a division...
Probably.
Wherever there's a division sign, I know that, like, rule of operations and all that exists, but I don't trust it.
Yep.
Right?
So that looks nicer
So
too. It's easier to understand.
Yeah, you've got 2 pi over 6, and then you're adding another 2 pi over 3.
Yeah. And so if I now grab that 2 pi over 3 bit and stick it, because you can see it's already just about in the right spot where we haven't done the y coordinate. And
Beautiful.
look at that. It's looking good. So that was adding 2 pi over 6 plus 2 pi over 3, and the next one, I could add it a second time, but there's probably a smarter way of doing it.
Yeah, you could just add 2 pi over 3 again, or you can simplify it down to just 2 pi over 6 plus 4 pi over 3.
Yeah. I'll go 4 pi over 3. And look
Beautiful.
at that.
So now if you just change all those to white.
Yep.
So that we get the proper effect.
Look, we can do multi-control. Let's go into proper play mode and click, and oh yes, look at that. Now that we've got this working and we've covered pretty much everything, I want to show something that's a little bit spin out and shows where you can take this further.
Yeah.
The whole reason where, if you go back to the start, we did everything based off this initial image.
So now if we move things around, like...
Oh yeah, so
if you move the base one around.
Yep, so if I move that one...
And you go, you know what, I want the fidget spinner to actually be over here.
And in fact, if you were really crazy, you could have code that actually moves the XY position and the whole fidget spinner would move around the screen.
You could.
But in terms of craziness, here's actually something that I did as an experiment. If I go insert controls and add a slider control.
Which was already on the screen.
Was already on the screen. There is our slider control. And so what I'm going to do is, I don't know what values to put in here yet, but if we come in to this one, and at the moment, and we look at the width property, width and height we're going to have to do. So the width is currently just 151 pixels or whatever the unit is. And so on this screen, I'm going to make, on this slider, I'm going to make the maximum 200 and the minimum 50, just for the hell of it, right? They're the values. And the current value, the default value can be 151, exactly as we have a thing. So if I come back to this one, if I make the width of this now equal to slider1 dot value, right? And then let's do it with a height as well, otherwise this won't work so well. So we'll go to the height property, and we'll make this one slider.
You cannot spell.
Slider1 dot value. Oh.
Do you need to take typing lessons?
You're making me think about it, which makes my typing worse. The width of this one, what I'm going to do is the width and height of each of these, instead of, so this one's going to be, the arms are going to have the same width as this one. So if I go, we called it circle dot width.
You can't spell circle.
Circle dot, you are making me very self-conscious about this right now. Circle dot height. Actually, we'll see if we can set multiple properties in a sec. Who knows? So if I go that one and that one, just like control select, and I went to height, and I typed in circle dot height.
Oh my goodness!
All I can say is I may not know how to type, but I checked that I can select multiple properties. Circle dot width.
So essentially, can't use a keyboard, but I can use a mouse.
Yes. Alright, so let's try this. Okay, so this time what's going to happen is all of those ones are changing. Yep, look. Ooh, look at this. Look at this.
You didn't change the gaps, but it just looks...
But that's still kind of cool.
I think I've seen fidget spinners that look like that, actually.
Really?
Yeah.
Oh, let's start the timer again. And then if I make it really big...
You can see it slows down as PowerApps kind of has to think about it.
That's still pretty cool.
Yeah, I like that one of the gaps isn't...
I like it. And then I guess if we were really, like, if we had enough time in our hands, we could make it psychedelic and change colours and do all sorts of
We could make
things.
it do so many things.
I know. So we've covered everything we wanted to cover. Hopefully you've got an idea of how we put this thing together. And I think, yeah, Ashlee was very, very clever in how she did this. But it also shows that PowerApps is actually quite adept and quite flexible in building some interesting interfaces. So hopefully you got some value out of that, and let us know if you have any questions or queries, and we might record some other ones.
Yeah.
Okay, bye.
Bye.